Hello, fourth graders. This is Miss Kay, and we are starting our brand new unit today, which is Unit 5, and we're going to learn all about geology in this unit. So here is some vocab to get started. A catastrophe is a terrible sudden event. Erupt, that's a verb, and it means to send out rock, lava, and ash in an explosion. So like volcanoes erupt. An observation is a noun, and that is when you're paying attention to something closely and gathering information like we do in science experiments. Evidence is proof, that's a noun. Fossil is a noun, and those are the preserved remains of something that lived long ago. A geologist is a noun, and that's a scientist who studies the makeup of the earth. Climate is a noun. And climate is different than weather because climate is the average weather in an area. So, for example, right now it is sunny outside, but in Syracuse, the climate for wintertime would be cold and snowy. Conclude is a verb, and that is when you decide on something based on information. Dense is an adjective, and that means thick or heavy. Hypothesis is a noun, and we know what this is from science, but it's an idea that might not be true yet. So it's a guess, it's an idea, but it was not proven true yet. And then continental drift is a process in which the continents slowly move over time on the surface of the earth. So our first chapter today is called Earth's Changing Surface, and let's read our big question. So we're looking at how did people's understanding of what was happening on Earth's surface change over time? If you had lived in Europe during the Middle Ages, the idea that the Earth changes would probably have seemed crazy. At the time, people believed that mountains, valleys, and other landscape features had always been there. True, rare natural catastrophes sometimes occurred. Earthquakes, for example, shook the ground and triggered landslides. In some places, volcanoes erupted and sent up fountains of lava or red-hot melted rock. However, people viewed these catastrophes as punishments from God, not as the earth changing. During the 1400s, 1500s, and 1600s, European explorers set sail on voyages of discovery. They found new continents and islands. Map makers created the first relatively accurate maps of the entire world. When people studied these maps, they noticed something interesting. Several continents looked as though they might have fit together like pieces of a jigsaw puzzle. Take a look at the world map or globe. See how the eastern edge of South America looks as if it fits into the western edge of Africa. If you could somehow push these two continents together across the Atlantic Ocean, their edges would match up. And this is showing the continent. So here is Africa, and you can see that this part matches up perfectly with this part right here. So people are wondering if the continents had once been joined and then later moved and spread apart. At first, this seemed like a ridiculous idea. How could the continents move on a planet that never changed? During the 1700s and 1800s, many people skilled in scientific observation became convinced that Earth's surface features do indeed change. They noticed how great masses of rock appeared to have been lifted up to form cliffs and mountains over time. They began to believe that once tall mountains had been worn down by wind, rain, and ice, and that over thousands of years, valleys had been carved by rivers flowing through them. These scientists found evidence that seemed to show that sea levels had been higher and lower at different times in the past. They found layers of rock on mountain peaks that contained fossils, the preserved remains of things that lived long ago. These scientists observed how big rocks gradually broke down into tiny pieces called sediments. They saw how new rocks formed as they observed volcanic lava cool and harden. And this is a fossil, and the caption says, fossils help provide information about the history of the Earth. All these observations led many scientists to believe that powerful natural forces were at work changing the Earth's surface. Most of these changes were thought to have taken place very slowly. Over long periods of time, slow gradual changes added up to produce dramatic results. These scientists were convinced that Earth's rocky surface had changed continuously throughout the planet's long history. It had changed in the past, and Earth was changing in the present too. These ideas laid the foundation for the modern science of geology. Geology is the study of the makeup of Earth and the forces and processes that shape and change it. Rocks are very important in geology. That's because rocks hold clues to how Earth's surface has changed over time. Together with fossils, rocks provide information about the history of the Earth. And this is Shen Kua. He was a Chinese scientist and mathematician. He lived from 1031 to 1095 CE. He studied rocks and fossils and made many observations of Earth's surface features. Shen Kua realized that Earth's surface is shaped very slowly by powerful forces. Some forces wear rocks down. Others make new rocks and push them up to become mountains. Shen Kua reached these conclusions hundreds of years before European scientists did. So what about the jigsaw puzzle fit of the continents? During the 1800s and early 1900s, geologists studied rock layers on the continents. They made many intriguing discoveries. For example, rock layers along the northern and eastern coasts of South America match rock layers along Africa's western coast. Also, deposits of coal and salt in eastern North America are similar to those in southern Europe. So this map is showing all those continents when they were closer together. And you can see that these colors match up with the types of rocks and fossils that are found. So right here and right here are similar types of rocks, which means that at one point they were close together and then they spread apart. Geologists found fossils of an ancient fern called Glossopteris in similar rock layers in Africa, India, Australia, and South America. They found fossils of an ancient reptile, Listosaurus, in both southern Africa and India. In South America and Africa, fossils of another ancient reptile, Kinognathus, turned up directly across the Atlantic Ocean from each other. These discoveries seem to indicate that the continents had once been joined, but how? Furthermore, how had they become separated? Several scientists proposed explanations, but they were quite far-fetched. One involved a gigantic eruption from the center of the Earth that ripped all the land apart. Another suggested that part of Earth's land broke away to become the moon, and what was left became the continents. Few people paid much attention to these ideas. A better explanation was needed, one with evidence to support it. In the early 1900s, Alfred Wegener provided just that. So this is Alfred Wegener. He was born and educated in Germany. He was interested in many scientific subjects, including weather, astronomy, and cold polar regions. Around 1910, Wegener read a scientific paper about similar fossils and rock formations found on different continents. He was intrigued by the mystery of the matching continents, and he wanted to solve this mystery. So Wegener gathered evidence. He pulled together discoveries made by many other scientists about rock formations, fossils, and mountain ranges. Polar explorers had recently unearthed fossils of Glossopteris in Antarctica. Similar fossils had previously been found in other parts of the world. This seemed to indicate that the ice-covered Antarctica might once have been joined to South America, Africa, India, and Australia. It also meant that Antarctica once had a climate warm enough for ferns to grow. From this evidence, Wegener concluded that all the present-day continents had been joined as one huge landmass long ago. He understood, as with any new discovery, that his conclusions might be altered or challenged in the future by more evidence. Nonetheless, he believed that the existing evidence supported his conclusions. If Wegener's conclusions were correct, then how had the continents moved apart? An important clue came from the ocean. the ocean was still largely unexplored in Wegener's day. In the 1870s, however, scientists discovered that much of the ocean's bottom was made of basalt, a heavy, dense rock that is formed when lava cools and hardens. Lava is magma that has erupted up above Earth's crust from deep underground. Most rocks that make up the continents are lighter and less dense than basalt. All right, I'm not going to read this part here, but this is showing how they made those discoveries. So they went deep down under the ocean and were looking at the seafloor to understand why these continents might have moved apart. So here's a picture showing the movement. You can see in this picture they are all close together, all of the continents. They slowly begin to spread apart, and then this is what our globe looks like present day. So this shows the dramatic change that happened over 30 million years. Think of the last time you put ice in a glass of tea or lemonade. The ice floated, right? Ice floats because it is less dense than water. Wegener thought about the fact that the rocks that made up continents are less dense than rocks on the seafloor. What if continents were like enormous pieces of ice? He wondered. Could they float over the denser rocks of the ocean bottom and move around? In 1915, Wegener published a book called The Origins of Continents and Oceans. And in it, he presented his hypothesis about how Earth's continents had moved over time. He called the process continental drift. Wegener proposed that millions of years ago, Earth had one huge landmass. He described it as a supercontinent and named it Pangaea, from the Greek word Pangaea, meaning all the earth. At some point, Pangaea broke up, and the pieces, or the continents, very slowly drifted away from one another. As the continents moved, mountain ranges pulled apart. Rock formations split. New oceans filled in the widening gaps between the land masses. Groups of plants and animals that had once lived together were separated. As the continents drifted, their climates changed. Antarctica's climate, for example, grew so cold that the continent's plants and animals died. Only their fossils remained, buried under snow and ice. Wegener's continental drift hypothesis explained the fit of the continents. It explained how matching rocks, fossils, and land features ended up in different places. It explained how the climate had changed on some continents too. Yet other scientists criticized Wegener's ideas and rejected his hypothesis. Why? It didn't explain how drifting continents actually moved. He had not identified a natural process powerful enough to slowly move enormous pieces of land across Earth's surface. There was a good reason Wegener hadn't found it, though. It was hidden beneath Earth's rocky crust. All right, so you have a few questions for reading. Number 1 asks, why might people have described this idea as crazy? So in the Middle Ages, why do they think that the continents moving is a crazy idea? Number 2, what did the scientists believe based on the evidence of Earth moving? Number 3 is true or false. The Earth's surface changed dramatically over time. Number 4, what is this map here showing? Make sure you use the caption to help you. Number 5 is true or false. Wegener and other geologists found that different continents had similar fossils and rocks. Number 6 asks you to go back to page 9. The author compares the movement of continents to ice in a drink. How is the ice similar to the continents? Number 7, what was Wegener's hypothesis about continental drift? And number 8, what did the other scientists think about Wegener's hypothesis? All right, let's move on over to skills. You've got some writing questions here. So number 1 wants to know, during this time period, what was the evidence showing that the Earth's surface has changed? How did these scientists realize that once, a long, long ago, the continents were not where they are today? Number 2, how did Wegener develop his continental drift hypothesis? Number 3, dense means thick or heavy. What are some examples of something dense? Number 4, what part of speech is dense? So if dense is something that is thick or heavy. Is that a noun, adjective, verb, or adverb? And then for 5, 6, 7, 8, and 9, I give you a sentence, and I want you to tell me whether that is an example of something dense or whether it is not dense. And that is all for today. I hope you have a great day, and I will see you next time. Bye, Adams.